So let's discuss some more examples of relations. So the question reads like this: check the following relation for being reflexive, symmetric, transitive, and just choose the equivalence relations, if any. So the first example of this question is A is related to B if and only if modulus of A is less than or equal to B. That is, A and B belongs to set of real numbers. So now we have to check for this particular relation. So discussing this, A is related to B. This is our given relation. So let's check for let's what are the set of real numbers? So let's first visualize. It's starting from minus infinity. So there are like -3, -2.5, and -1, 0, 1, 2, 2.5, 3 goes on. And you don't have to do it this particular thing in exam. I'm just writing so that you'll be able to better visualize things. Now coming over to checking, first of all, reflexive, about reflexivity of this particular relation. So if you take A as -3, so we will take random examples from the set. So taking A as -3.5, B also as we are talking about reflexive as minus of 3.5. So let's write it here. -3.5 modulus less than equal to minus of 3.5. This will become 3.5 minus 3.5. Is it true? Is this statement true? Is this inequality true?
No, sir.
No, it's not. So given from first example itself, we are able to prove that this is not reflexive. So we'll write in NCERT format, not reflexive. Given relation is not reflexive. Let's check about the symmetry. Let's check about the symmetry of the given relation. So symmetry means if we say A is B modulus of A, so can it be possible that the modulus of B will be less than A? Then only AB will be belonging to the relation and BA will be belonging to the relation. And if it is so, then we will be able to announce this particular relation as symmetric relation. Now let's check whether it is possible or no. So whenever we are checking, we have to try hard that to prove the given relation as otherwise of whatever we are checking. We have to look for the examples that where we can prove that the given relation is not reflexive, not symmetric, not transitive. And if we are failed to do so, then it is for sure that the given relation is reflexive, symmetric, and transitive. In each case, whatever we are discussing about. Clear? That how we have to check?
Yes, sir.
Yeah. So taking simple example here, taking A as 1 and B as 2. So one's modulus is, so 1 is greater, 1 is less than 2. So it is true. Let's check for now B taking as 1 and A as 2. Okay. So whether it will happen so or not. So the relation is same only. This because we have taken B and A. So A as modulus of 2 less than 1, 2 modulus of less than 1. Is it true?
No, sir.
No. So that's why this is not symmetric. Symmetric relation नहीं है. Okay, not reflexive, not symmetric. Now let's check for transitive. What do you think? Is it transitive or not? No. Is it transitive or not?
Yes.
Yes, it is. Why? Just give me the rough idea which you were thinking about. It's no problem.
No, it agrees with all the rules for the transitive.
Hmm? Can you prove it? Let's take A as -1, B as 0, C as 0.5. So whether the first, if all these three conditions satisfy, then the relation is going to be transitive. If these two are givenly satisfying, and further on this particular condition is satisfying, then the given relation will be transitive. Looking for the first example, 1 is less than 0. Is it true?
Yes.
Is it true?
No, sir.
No, it's not.
It's
Let
actually -1, no.
But it's our necessity to make these
To make it more.
conditions satisfied by ourselves. Then only we can check for the transitivity condition, which is this. So let's take minus. Okay, let's take for our convenience, take A as 0 and B as 0.25. So this true now, like 0 is less than 0.25, correct?
Yes, sir.
0.25 is less than 0.5, correct?
Yes, sir.
From these two, can we write 0 is less than 0.5?
Yes, sir.
And it will be true for every number. Even if we take like all negative numbers. Now what we are doing, we are brainstorming on this. Whether one condition, well, when we considered one example, it was true. Now let's take more examples. And you do not have to take examples all the time. Like this is very short. This relation we can easily visualize whether two numbers of same nature will be available there or not. Like if we check for the reflexibility, so think for whether two numbers, if you take a same number, whether they will um, they will satisfy this particular condition for the relation or not. If you take the same numbers like A and A, so yes, it is doing so, but we have to be skeptic while doing so. Let's check for some two negative numbers like -a and -a. So the right hand side will become -a and -a. So right hand side will become this, and so but this condition is not satisfying. Simply reflexive norm. Symmetric. Um, if if it is a condition of inequality, then definitely the B will not be going to less than A. It's a common sensical. So, okay, symmetric is also not that. But when we talk about transitive, so while writing these three conditions only, we'll be able to, you will be able to make a guess, make a understanding, make an intuition by seeing just then, yes, it is going to be, we can write, so after these two conditions are satisfying true, so it may be written, it's just a simple property of inequality. After drawing these two conclusions, we can draw the third conclusion very easily. But still, let's take examples as we are just beginners in relations example and practicing for the start. And trust me, mathematics cannot be learned by just lectures. You have to practice a lot, and that will develop you a mathematical understanding, and you'll be able to intuit things like how we make intuitions in our real life after having a lot of experience. It's the same with mathematics question as well. Okay, so let's take all the negative examples. -3, p is -2, and we have to ourselves satisfy these two conditions and then check for the third. This is our responsibility to satisfy these two. Okay, so in this will be very satisfied. Yeah. Oh, okay. No, 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 no. It won't be. Mhm. So what we can do? We cannot take a negative example here to satisfy these two conditions. Because for checking transitivity of any relation, what we were doing, there were given two conditions already satisfying. Let me, yeah. So here, a relation R on a set A is said to be a transitive if AB is belonging to the AB is belonging to the relation and BC is belonging to the relation. Then if it implies that AC will also be belonging to the relation, then we may call it as a transitive relation. So this was a condition that this has to be given, and then further this depends whether the relation will be transitive or not. Any doubt?
No, sir.
Okay, so we ourselves have to satisfy these two conditions, which is not happening in the case of negative numbers. We cannot just, because the negatives number on the left hand side is becoming positive, and it cannot be less than or equal to a negative number. So positive number here will not be less than or equal to a negative number on the right hand side. That's why we're not able to take this example. So let's drop the idea. And from basic understanding itself and from the previous example, we can conclude that the given relation is transitive. Okay, so the final answer becomes for the question that this is reflexive, not reflexive, not symmetric, and only transitive. Clear? Any doubt?
No, sir.
Okay, let's take one more example. Do you see any doubt?
Sir, no, sir.
Okay. A is related to B if and only if modulus of A minus B is greater than half, where AB is belonging to set of real numbers. Okay, so discussing this question, A is related to B if the difference between these two is greater than half. So let's check for reflexive relation. So if we take any two numbers like same numbers A and A, whether their difference will be zero, right? Is zero, the difference will be zero, and will zero be greater than half? Is it so?
No, sir.
No, so it's not reflexive, symmetric. If we take two numbers now, and their difference is greater than half, if we check for whether A belongs to a relation or not, so B minus A must be greater than half. So is it similar to writing A minus B? Because modulus is there, right?
Yes, sir.
Clear, or should I like elaborate on this?
Could you elaborate for that?
Yeah. So if A minus B is written here, so let's say 5 minus minus 4 or minus this is written. Okay, so let's take any two numbers, 5 and 3. If it is written, it is greater than half, so it is what, 2. And simply if we reverse that, 3 minus 5, and what is this? Minus of 2 modulus. Minus 2 modulus is 2 only, so it's the same. minus modulus of 5 minus 3 and 3 minus 5, because the sign is only going to remain positive after solving modulus function. Clear?
Yes, sir.
Good. Now let's check for this. So if these are the same things, so we can write it as this, which is already true from the condition. So yes, it's going to be symmetric. Okay.
Yes, sir.
Yeah. Now let's check for transitive. So if it is given that a minus b is greater than half and b minus c difference is also greater than half, maybe write that a minus c's difference will also be greater than half. Can we do that? So let's take an example, because there will be changes, like if they are opening like a, they can be open like in these two. The modulus can be open in this way. Okay. If we are writing this, so this have two meaning manifestation. B minus C's, maybe its difference is half. C minus B's difference is half. I have explained it earlier also. Okay.
Yes, sir.
So if this is the case happening, let's understand. Let's consider if this is the case happening here, and this one is the case happening. So if we add these two particular equations, 1 and 2, so on adding on left hand side, a minus b plus b minus c will be greater than half plus half 1. So b cancels, a minus c is greater than 1. So if a minus c is greater than 1, maybe write that a minus c's modulus is greater than half if it is greater than 1 only, 1 itself. So maybe write what a minus c is.
I couldn't understand this, sir. The last one, A minus C.
So what we have done, there are like two meanings of this particular given condition, that let me represent it properly. We have less time to cover this syllabus. Yes. If transitive, so it is given to us that a minus b's difference is greater than half, which is saying that AB belongs to the relation, and B minus C is greater than half, which is equivalent to saying that BC is belonging to the relation. Now we have to check whether AC is belonging to the relation or not. If it is belonging, then we will write the given relation is a transitive, otherwise not. So do you understand till now?
Yes, sir.
So considering these are given conditions, like they are true. Okay. Now this have two meanings. A minus B's modulus can be opened in this way or this way. I have explained it earlier. If you have any doubt, I'll repeat. Any doubt?
No, sir.
Modulus of some function can open in two ways, depending on how which a, if a is bigger or b is bigger. If a is bigger, then it will open like this. If b is bigger, then it will open like this, to make the overall function as a positive entity. Any doubt?
No, sir.
So okay. C minus b is greater than half. So let's say that this is one this particular condition is opening like this, and this is opening like this. Okay, we are considering that a is greater than b and b is greater than c. So in this scenario, if we add up 1 and 2, so a minus b plus c minus b, sorry, A minus B plus B minus C. Half plus half becomes 1. This cancels this. This can be written as A minus of C is greater than 1. If something is greater than 1, it is of course greater than half. True? Yes or no?
Yes, sir.
Yeah, so it means that A and C is belonging to the relation. So if only these two possibilities were falling out, so we may conclude that the given relation is transitive. But there are other conditions, there are other manifestation as well, which are there. What if this becomes a reality in third case? Then what will happen? Let's check what will happen. Let's add 1 and 3. A minus B plus C minus B is greater than half plus half becomes 1. So this is A plus C minus of 2B is greater than 1. So from this, we cannot conclude that A minus of C is greater than half or not. Okay, and even if it is looking complex to you, I can also take some examples where the A minus B has to be greater than half. So it is given that A minus B is greater than half and B minus C is greater than half. Now we have to check for A minus C is greater than half or not. So let's take A and B as per our convenience as these conditions are given. So let's take A as 3 by 2 and B as 1 or half simply. Okay. So this will be satisfied? Yes, 3 by 2, 1.5 minus 0.5, 1 is greater than half. Okay, done. This is satisfying for this given assumptions. So half minus, if we take C as, if we take C as minus of half, so half minus of minus, so what will happen here? B is half, minus of minus half, it will be positive. So 1 is greater than half. Yes, this is also satisfying. Now let's check for these particular numbers whether this condition is satisfying or not. So A minus C, 3 by 2 minus of C. So this becomes this only 1 by 2. So this is 1.5 becomes 2 is greater than half. Is it true?
Yes, sir.
This is so for these particular numbers, it is satisfying. But let's take some more example because in hindsight, there's one doubt because what if like there are different conditions happening and not everything is matching up. Let's take one example where A minus B was greater than half, B minus C is greater than half. Okay, so taking A as 1 and B as minus, this time taking B as negative. So 1 plus 1, that's 2. That's fine. Let's take C minus of 1, minus of 1 and minus 1, minus 1.5. So yeah, take says 3 by 2. Here minus 2 and 2 will be greater than half. Okay, this is also satisfying. Now let's check for A minus C, whether it will be greater than half or not. Now we have conveniently taken C as only on the difference of half only. Like one is, what is the difference in between these two? A minus C, 1 minus 3 by 2, more or less, 1 minus 1.5 is minus of 0.5. So its modulus, it becomes 0.5. What is 0.5? Half, which is not greater than half, right? So the given relation is not transitive. It was like an intuition when we felt that there are two manifestations, and what if this is staying true and the other one is staying true in the other case? Then what will happen? Okay, that was the reasoning behind taking so much examples. And if you can believe on your reasoning and gut, then you can mark your option directly. Any doubt?
No, sir.
So we have spent enough time on relations. Now let's go on to functions. Okay. Any doubt from relation?
Sir, no, sir.
Good. So let's discuss about functions. So functions are basically relation only. What was relation? First of all, we were discussing about two sets, A and B. We have taken their product, Cartesian product, and which was x, y, such that for all x belonging to set A and y belonging to set B. So whatever was possible to write here, any x, any element of A and any element of B was the Cartesian product. Now we have taken certain subset of this Cartesian product, and that was our relation. So now in this particular relation, there was a pattern, there was a reasoning behind the relation between x was somewhat related to y. Now we are assessing this particular relation between two coefficients, between two variables, and if it is happening in a certain way, that we may announce the given relation as function. And what are those conditions? We'll discuss later. So let A and B are two non-empty sets, then the subset of A, the Cartesian product of A and B, which is a relation, the subset of Cartesian product is relation, is known as a function from A to B if and only if for all A, for all elements of set A belongs to set, like all elements of set A, there exists a unique element in set B such that AB is existing in the F is the given relation. And function is denoted by F of A to B, or it may also be written as this. Function is also known as mapping, transformations, or operators. Basically, function is like a machine. Function is like a machine. Let me tell you the features of this machine. So this is a machine. Which has a way. If you give any input in the machine, it will provide you a specific output every time. Like machine itself will not eat your input. So for every input, there has to be a unique output. Unique output, why? Because it will depend on the nature of input. For like a specific input, there will be a specific output. And for another input, there will be another specific output. Okay. So my point is, for a single value of input, that is x, there has to be a unique output. That is y. What is function? F of x is known as function. So y is the output, x is the input here. For every input, there should be unique output. There has to be a unique output as per the input in codomain. Codomain means set B. Okay, and where all the inputs will come from? Set A, because the function which we are discussing about is going from A to B. And this should be unique output. Why unique output? So if we like, if we put some different nature, some different input, then there has to be different output. That's why the uniqueness of output is related to input. And also there has to be a output every time. machine will not, like the function will not eat the variable or the input. It has to give some output. Okay. So this is a simple condition. From this, we can derive three conditions from this simple statement that for all elements of set A, there has to be some output. There has to be some output. There exists a set, like, there has to be this ordered pair where A is the input, B is the output, B belonging to the set B. So for every input, there has to be an output which should be unique. And the output must be, which is B, must be belonging to the codomain. Codomain. If we are like, we are operating on certain machine, so it will act as per the machine only, na? As per the codomain itself. It will not produce babies. It will not give potatoes. Okay. So that's its codomain. It has to be act. It has to act in a certain manner. So these are condition. Simply remember the definition or this simple statement. This simple statement. For every input, there should be a unique output in codomain for for announcing a relation as a function. Okay, let's go back to the definition. Now we'll be able to relate it well. Let A and B are two non-empty sets, then the subset of the Cartesian product of both is known as f is known as a function from A to B. Now condition starts. If and only if for all element of set A, there exists a unique element in B. There exists a unique element in B such that AB is belonging to the function, is belonging in the relation. Okay. So let's take examples, then you'll be able to understand it well. So please, can you please tell me the domain of this given relation?
1, 2, 3. Two, three, four, five.
One is mapping to 2. 2 is mapping to 3. 3 is mapping to 4. 3 is also mapping to 5. Now the problem here is that for every input there should be unique output. So for every input there is an output. Okay, not a problem here. There should be a unique output in codomain. Unique output. But here, what we are observing,
3
what we are
is two outputs.
yes, 3 is having 2 outcomes. So that's why the given relation is not a function. And what is acceptable if like every element is mapping? Okay, it is acceptable. And also, if two inputs are having a same output, this is acceptable. This is known as a many one function. So there, for every like input, there should not be two outputs. There can be same output for two inputs. So that's a bit confusing also, but we will be understanding using an analogy that will clear all your doubts. Let's discuss about this. The domain range here is 2, 3, 4, 5. It is the same. Yeah, it's the same. So no use of discussion. This is also not. This is the same. Okay. So how to check whether the given relation is a function or no? So this is the concept behind that. Now let's talk about the method. First method is if graph is given, then we have to use this method. This test is particularly used for visualizing functions on a graph. So let's take a graph. Sick. This is a parabola. Like y is always positive, so it will be opening towards positive of y. Y is equals to x square. So for all values of x, it will be also touching the origin. Parabola will be facing the positive y. So please understand this is a parabola. Okay. So vertical line test. So plot the relation, graph the relation. Okay, we have graphed. Now draw vertical line. Imagine drawing a vertical line parallel to y-axis. Parallel to y-axis. So we have drawn a parallel line to y-axis through each point on the x-axis. Okay. Observe intersections. Check how many times each vertical line is intersecting the graph of the relation. So how many times the line is intersecting the graph? Only one time. So if every vertical line intersects, right, we have to draw many. Sorry. This is parallel, this is also parallel. So like this. So all the vertical lines are intersecting the graph's curve, like the curve's graph, only once. So if it is once, then the relation is a function. Okay, so this relation between y and x is a function. Okay, now let's discuss x is equals to y square. This is the graph. Now x is positive every time, and this will be in the origin. Now, if we draw parallel lines, how many times it is intersecting? Twice. Twice. Clear? This is the graph of x is equals to y square, parabola. If any vertical line intersects the graph more than once, then the relation is not a function. So this relation is not a function. Clear? Now let me tell you why. When we're discussing about this, so by drawing vertical line, what is this vertical line? There is a constant value of x here, and throughout the line, we are checking that for a particular value of x, there is only one intersection. Means for single x, for one input, there is only one output. Now here in this case, for one output, for one certain value of x, there are two y's. There are two outputs. That's why this relation is not a function. Clear?
Yes, sir.
Please read the slide once. Done?
Yes, sir.
Any doubt?
Sir, only that x equals to y square graph. Could you repeat it again?
Okay, how to draw it?
No, not that one. Like, you are saying no, it's not a function. Only that one.
Okay. So why it is not a function? If the vertical line is intersecting the curve of the curve, then it's not a function. Okay. Now, what's the reasoning behind it? Because for this uh, for this particular value of x, let's say this is 2, this is 2. Okay. For x being 2, for x, as x is 2 here, y square. So how will x, sorry, y is equals to plus minus of square root 2. So this is plus of root 2 and this is minus of root 2. There are two intersections. Like for a single value of x, there are two output. For a single input, there are two output. That's why this relation is not a function. Clear?
Yes, sir.
Okay, now let's move ahead to algebraic check, where we simply are not drawing any graphs and we are checking about the algebraic representation. First of all, we have to identify the set of ordered pair. To get the set of ordered pair, basically I suggest map the relation. Okay, write the set A, set B. Set B is codomain, and this is domain. And the particular elements which are getting mapped only, that is the range. Now, what you have to check that the every element of domain is getting mapped. This means, okay, let me write it after it. And for every input, there is a unique output. And it may happen that for two inputs, there is a single output. That may happen. But there should not be multiple outputs. No multiple outputs for a same input. That's one clear statement. You should not leave any doubts in your head. So, okay, these are two conditions, and this much only. These two conditions you have to see in the after doing this. So now let's check what is written here. And so that each value of x in the set maps exactly only one value of y. Okay. If each x value has a unique corresponding y, so it's this. They have missed this point that every element of domain has to get mapped, because for every input there must be some unique output. This set A is domain, this is codomain. Okay, the elements which are getting mapped in codomain are range. So it may happen that some elements in the codomain are not getting mapped. So no problem with that. It's just that every element in the domain, that set A, has to be mapped. That's the condition. Any doubt?
No, sir.
Now please read the slide.
Yes, sir.
Any doubt now?
No, sir.
Domain, codomain, and function. Okay, let A, F, then set A is known as a domain, B is the codomain, and set of all images of elements A is known as the image. Image set is denoted by F of A. And it is also range. Image of F or image set of A is also known as range. F of A is a subset of set B, which is the codomain and f of a is the range. Clear?
Yes, sir.
No doubts? No doubts. Okay. Now let's discuss about different types of functions. There's many one functions. So it may happen that for two input, there can be one output. So if it is happening so you may declare the function as many one function. If two or more than two elements have the same image in B, then f is said to be many one function. If the function is x square, like for 1 and -1, the value is 1 itself. For 2 it is 4. So for two inputs, there is same output. This is a function, no problem. It has not to be otherwise. This should not be happening. There's a special analogy given by Neha ma'am. Yeah, Neha ma'am on YouTube. She says that the set A, set B. So this is a set of mothers. This is a set of children. So two children can have yeah, two children can have same mother. Is that is possible, right?
Yes, sir.
Yes, sir.
Yeah, but no one children can have two mothers. Okay,
Yes,
so
sir.
remember like that A set is related to AC, EC, BM. So AC means that A set is a set of children, B set is a set of mothers. So two children can have one mother, that's okay. Two inputs can have one output, that's okay. But uh, one children cannot have two mothers, that's not okay. So it means one input cannot have two outputs. Simple. Clear? This is the
Yes.
one way we can learn. Any doubts? Many one function?
No, sir.
One function. It is also known as injective or injectivity is the property. Okay, let's discuss about this once. When f is said to be one function or an injective, if different elements of A have different images in B. So one children, one mother, one children, one mother. Okay, every mother is having one children, and every set of element are getting mapped here. So like every element in the domain is mapped to one element. May happen like this also. This is also possible. This is also injective. Clear? Any doubt?
No
No,
doubt.
sir.
Now for checking one function, if A is not equals to B, if two inputs are not equal, so their output should not be equal. This is one condition. And if we have assumed this, we do it in NCRT, assuming f of A equals to f of B, and if it turns out, if it says that A has to be equal to B after solving this equation, then we may call the given function as 1. If it is not happening, so if it is happening something else, if it is like minus of A is equals to B, then the given function is not 1. Clear? First we assume this, and if this is the conclusion, then we may call that the given function is 1. If it is not the conclusion, then we say the given function is not the one function. Clear?
Yes, sir.
Please read the definition here, specifically this. Clear?
Yes, sir.
Onto function or subjective. So if I there's a function from A to B, if every element in B, this is B, every element in B has at least one pre-image in A, then f is said to be an onto function. Simply, every element in set B is getting mapped. Then the function is onto function. And technically, we may write it as that set B is codomain. And if every element is getting mapped, so like the set of every element getting mapped, the set of second element in the relation is range. So if codomain is equals to range, then we may call the function as onto function. Clear?
Yes, sir.
And the relation is this: f of x is 3x. Now let's check. Set A is 1, 2, 3. Here is 3, 6, 9. Okay. 4A and B. A1, 3, 2, 6, 3, 9. Every element is getting mapped. So codomain is equals to range. Okay. So this is onto. So this is surjective. And every element has different, every input has different outputs. So it's like straight lines. So one function. True. So it's injective also. Okay. Any doubt?
No, sir.
Yeah. So if a function is onto and one both, so we may call the function as bijective. Bijective function. Okay.
Yes, sir.
Into function. If a function is not onto means codomain is not getting completely mapped. So it's an into function. Simple. If there exists even a single element in B having no pre-image, like 7 is left out. So this given function is into function. Onto was codomain was equaling to range, and here it's not the case. That's why it is into. Simple. Okay. Clear?
Yes, sir.
So if a function is one and onto, it's said to be bijective function. A bijective function is also known as one to one correspondence. In other words, the bijection, if it is one, if the condition is rated, it is onto, there exists codomain is equals to range. Means for every element of P, there exists some element in set A, it's getting mapped. Read this once.
Yes, sir.
Any doubt?
No,
No,
sir.
sir.
Yeah, so it's about bijective constant function. So simple. It's like f of x, 5. Okay, f of x, k, where k is a real number. So it's like some fixed number. Let a function be defined from A to B is defined in such a way that all the elements in A have the same image in B, then f is said to be a constant function. So like say there are different elements in codomain. Let's write it as 4, 5, 6, and 1, 2, 3, 4, 5. Every element is getting mapped to 4 only. 4 only. So this is a function This is a constant function, not depending on the input. Okay, any doubt?
No, sir, no doubt.
Yeah. Identity function. Let A be a non-empty set. Then the function defined by identity function for all x belongs to A is called an identity function. Like there is a function starting from A to A, and whatever input you have, like the function is y is equals to x. Okay. So if you give it any element, it is happening, it is on the set A, which is 1, 2, 3. So for 1, y is 1 only. So 1, 1. For 2, it is 2 only. It's like identity relation. Okay. Clear? So if it is a function from A to A only, so domain is A and codomain is also A. 1, 2, 3. 1 is getting mapped to 1, 2 is getting mapped to 2, 3 is getting mapped to 3. So this is 1, 1 and on 2. Yes. So this is clearly a 1, 1 on 2 function with the domain A and range A. Clear? Or should I explain something more?
Yes, sir.
Yeah, equal functions. Two functions f and g are said to be equal. Written as f is equals to g. They have the same domain. They satisfy the same condition. And they satisfy the condition this. F of x is has to be equals to g of x for all x. And they have same domain. So basically they are equal functions. They're same. And doubt? Let's say f of x is x square. And g of a is a square, where x domain is real number, a's domain is also real number. They are equal functions. Fine. The domain are same. Okay, domain are same. And f of x is equals to g of a. Because it's like x square is equals to a square. X is the variable of this particular function. And a square is the variable of this function. And both x and a have same domain, same input. So of course their result will be same. That's why they are called as equal functions. Any doubt? Any?
Sir, any example for this?
I have just given
No, any more because it's a bit confusing.
equal function is simple. It will not be of use anywhere. It's like two equal functions only. The same functions, they are equal. Um, see, x of u, where x domain is natural number, let's say, and z of in some other variable. It's like the variable is only different and all is same. The variable is only different. Like the letter which we are assuming, which we are denoting it by, this is the only difference in both of are the same. Okay.
Yes, sir. So now f is one function and g is one function. Now clear, sir. Yes, sir.
It's just like letters are different. Their work is same.
Okay, okay, sir.
The clothes are different. Even in node function, it's very important. F of minus of x of x. Then it is even function f of minus of x is equals to minus of f x. Then it is odd function. I've also covered this earlier multiple times. Any doubts?
No, sir.
Okay, so let me give you an example. For f of x is equals to x square, if we take minus x here, so minus x square is x square itself. So if it is x square was f of x. So yes, f of minus x is getting f of is equal to f of x. So that's why the given function is even. F of x is equals to x cube minus of x cube. That's minus of x cube. So x cube was f of x. So f of minus x is equals to minus of f of minus of f(x). This is odd function. This is even function. Okay.
Yes, sir.
Here. Shall we discuss? When is the next class?
7:15, sir.
Okay, so we'll discuss it later. Any doubts?
No, sir.
So please solve questions by yourself. Look for examples in NCRT and solve them. And if any doubts, bring them here or send them in on the WhatsApp group. Okay.
Okay, sir.
Please practice. Yes. Thank you.
Thank
Jai
you,
Thank
sir.
you, sir.
Jai.